Here's the GOES 16 water vapor imagery at 6.9 microns, along with the 500 millibar heights overlaid. The obvious feature is this closed low over California. We have a lead shortwave in Arizona that's moving towards the northeast. And out ahead of that lead shortwave, if we focus in on this region, you can see indications of ascent with cooling brightness temperatures over New Mexico and Colorado, likely associated with an upper level jet. If we move on to confirm what we see in NWP output with GOES imagery, over here in the upper right we have our GFS 500 millibar vorticity, and it nicely shows this vortmax in Arizona moving off to the northeast, and we can easily see that over here in the GOES air mass RGB product, and also very nicely here in the 6.2 micron water vapor band. Over here in the lower right we have the GFS 250 millibar isotax, and you can see this jet streak oriented just ahead of that lead shortwave, and it's situated over Colorado and New Mexico. And recall the cooling brightness temperatures indicating ascent over this region that we saw in the 6.9 micron water vapor imagery from the previous slide. Well, we see indications of that in the imagery here as well. Here's the MSLP surface-based CAPE and surface winds from 4 different models: the GFS, Euro, NAM, and RAP, all initialized at 12Z. If we advance a little bit forward in time to 15Z, and then I'll go ahead and stop it here at 18Z, you get the impression of a surface low approximately right in here, and a dry line extending southward from that. And just east of this you have this higher area of CAPE, so we have a warm front just northeast of the low. And if we go to a little bit later in time, these winds back around more, and you have this warm front moving more towards the northwest. So we're essentially advecting in higher moisture from these areas further to the east, developing a region of higher CAPE just out ahead of this low. And here's how it looks by 0Z in the evening with that developing low in southeast Colorado. Now if we switch to just the surface dew point and winds from the same 4 models initialized at 12Z, I'll advance along slowly to 15Z and then 18Z, and just notice the enhanced convergence that you see near that surface low where the different air mass boundaries intersect, and convective initiation would be likely in this region. That warm front just north of the surface low you can see quite nicely with the region of backed winds helping to advect in these higher dew points in this area just north of that surface low. So monitoring observational data for precisely where and when this happens will be important. The most representative 12Z sounding for our area is from Dodge City, Kansas. Note the nearly dry adiabatic mid-level lapse rates. Low-level moisture is plenty deep. This is the source region for moisture in southeast flow for southeast Colorado. And note the wind profile has good directional turning, and we expect mid to upper flow to increase during the day, providing for a favorable shear profile for supercells. Next we'll look at output from the HREF. This is the composite reflectivity greater than 40 dBz ensemble paintball initialized at 12Z. We start at 17Z and begin to see ensemble members showing storms in southeast Colorado soon thereafter. By the time we get to 20Z, we see numerous ensemble members with storms in southeast Colorado. And in time, the trend is for more widespread convection that moves off towards the east. If we move on to the 4-hour max updraft and ensemble max, by early afternoon we see numerous ensemble members with max updraft regions in southeast Colorado. Through the afternoon we see an increase in magnitude and coverage over southeast Colorado, while eventually moving eastward by later in the day.